All right, now that we've got a handle on oxidation numbers, we want to come back to why are they useful? Remember that the goal of oxidation numbers is to tell where the electrons are and how they're being transferred. So now we're going to apply this to a balanced chemical equation to tell, is this reaction a reduction oxidation reaction? Is there even a transfer of electrons? And if so, which species is being oxidized? That is, which species is losing electrons? And which species is being reduced? Which element in the chemical equation is gaining the electrons? So to answer these questions, we're going to assign oxidation numbers to all the elements on the reactant side and the product side, and then compare those. So if there's no change in any of the oxidation numbers, then it's not a redox reaction. And we can also see if the oxidation numbers are changing, are they increasing or decreasing? Here we have some more practice figuring out which species is being oxidized and which is being reduced in a redox reaction. So remember that we want to start by listing out all of the elements on each side and finding their oxidation numbers. So here we're starting with nitrogen and hydrogen, and on the product side, nitrogen and hydrogen. Now, N2 is elemental form, so it's going to have an oxidation state of 0. Same with H2, those are both diatomics. Elemental hydrogen, oxidation state of 0. Now, when we move to the product side, we have NH3, so that's hydrogen bonded to a nonmetal is going to have an oxidation number of +1. And then nitrogen is bonded to 3 hydrogens, so to counteract it, we'll have an oxidation state of -3. So now we definitely see some changes here, and in terms of oxidation states, hydrogen is going from 0 to 1. The oxidation number is increasing, so we say that hydrogen is the one that's being oxidized. And since nitrogen is going from 0 to -3, that's a decrease, so nitrogen is being reduced. Now in our next example, we have a little bit more going on because we have iron, we have nitrogen, and we have oxygen. And then over here we have aluminum. And then on the product side, we still have aluminum, nitrogen, oxygen, and iron. Now notice that this is an ionic compound, FeNO3 So if you reverse your swap and drop, the iron here is going to have a charge of +2. And since it's ionic, that's also its oxidation number. Iron has a charge of, or an oxidation state of +2. Now notice that NO3 is the nitrate ion, so I'm going to consider just NO3 minus. Oxygen, of course, is -2, and to give an overall charge of -1 on the polyatomic ion, nitrogen has to be a +5. Then moving over to aluminum, this is elemental, not bonded to anything, so oxidation state of 0. Now on the product side, we have aluminum nitrate, but this time we have 3 nitrates, which tells us that the aluminum has to have a charge of +3. Now the nitrate ion hasn't changed at all, so oxygen is still -2, nitrogen is still +5. That whole polyatomic ion is unchanged. But iron over here is now in elemental form with its oxidation state of 0. So we see in terms of the changes that iron is going from +2 to 0. So we would say that iron is being reduced. And we notice also that aluminum is going from 0 to +3. So we say that aluminum is being oxidized. All right, now we have 2 more examples. This first one starting with elemental chlorine and sodium iodide. So we have those 3 elements. And then we have elemental iodine and sodium chloride. In terms of oxidation states, an element is always 0. Sodium in an ionic compound is +1. And halogens, generally speaking, are -1. Now on the product side, iodine is elemental. It's no longer bonded to anything, so that's a 0. Sodium is a +1, and chlorine is -1. There we go. So to get your changes, what's being oxidized, what's being reduced, chlorine is going from 0 to negative. So chlorine is the one that's being reduced. And sodium isn't changing, but iodine is going from -1 to 0. That's an increase. So iodine is being oxidized. And for our last one, we have lead sulfide. So lead and sulfur and hydrogen peroxide. So we've got hydrogen and oxygen. And in the products, we've got lead, sulfur, oxygen, and over here, hydrogen and oxygen. So we know that sulfur in ionic compounds has a -2 charge, and therefore lead has to have a +2 charge. And in hydrogen peroxide, remember that that's our exception to the rule for oxygens. It's only going to have a -1 oxidation state there. Well, hydrogen bonded to a nonmetal is a +1. Now in the products, you should recognize the sulfate ion as having a -2 charge. So lead has to have a +2 charge to make it neutral. Now oxygen here is no longer peroxide, so it's -2. And sulfur, to balance everything out, is going to have to be +4. No, +6. Change that. There we go, get that fixed. Oxygen is -2, sulfur +6, oxygen, there we go. And lastly, we have water, oxygen with its -2 like usual, hydrogen with its +1. Now, if we look at the changes, sulfur is going from -2 to +6. That's definitely an increase. So we say that sulfur, its oxidation number is increasing. It's being oxidized, which means that it's losing electrons. And oxygen is going from a -1 to a -2. The number is dropping. Oxygen is being reduced.